Hi, folks. We're going to take a look at 3D from the Unit 6 Lesson 2 worksheet. And it's an example of graphing a combination of functions when you're given the graphs of the two original functions. So notice here we don't have the equations of these functions. We're going purely by their individual graphs. So here I'm looking at graphing f divided by g. Okay, and I'm going to try to follow a similar pattern to other questions. I'm going to start with looking with one of the easier characteristics, which is the x-intercepts of this combinations of functions. So since this is equal to, I can find y values by finding f at x divided by g of x. I realize that my x-intercepts are just going to be wherever the numerator is 0, as long as the denominator is not also 0. All right. So here, my numerator is going to be f at x, this one that kind of looks like a cubic. So it's equal to 0 here, and the g is not 0. So here I've got an x-intercept there, here, and right there. Now, in terms of other nice points to get, and things, when I say nice points, I mean things that can be found very easily. I realize since I'm dividing two numbers, I can easily determine where that's going to be equal to 1. Wherever f at x is equal to g of x, in other words, wherever they intersect, the quotient is going to be equal to 1. So those are some nice points. So here I see they intersect, so I divide them. It's equal to 1. So there'll be a point there. Here they're equal, so point there, more or less. Just try to be as, it doesn't have to be perfect, but just has to be reasonable. And then here, just right above. Okay, and those might be helpful for sketching the graph. Now, I can also probably figure out where they're equal to -1, where they have the same absolute value but opposite sign. But I don't, I'll see if I need that. If not, I'll just try to sketch it without looking for those points. All right, so the next thing I'm going to do is I'm going to look at where the denominator is equal to 0, because that may be the location of my vertical asymptotes. All right, so here g is equal to 0 at -3, and f is not equal to 0. So that means that I'm going to have a vertical asymptote at -3. Okay, and similarly here at +3, again, I have some number not equal to 0 divided by something that is approaching 0. So I'm also going to have a vertical asymptote at +3, x equals +3. Okay, so here are my asymptotes. Now let's see if we can figure out what's going on where this function g has an asymptote. What's going to happen when I take f over g? All right. So this is one of these things that's not clear cut. So we're going to have to do a little bit of analysis here. So I'm going to start by looking to the left of -1. All right. And let's take a look at the behavior of the function f in the numerator. Well, that's equal to, some number just above, maybe 3.2. Okay. So these are y values just above 3. And they're being divided by numbers that are getting very, very, very large. So what happens when I take some number like 3.5 and divide it by something very large, it's going to be close to 0. So I see that this is not going to be the location of an asymptote for the function f over g, but it's going to be approaching 0. Now, it can't approach 0 and get there because we know that this function is not defined at -1. So that means there has to be a hole there, all right? Because clearly the denominator's not defined, so the whole thing cannot be defined. Let's see what happens to on the right of -1. So again, f, the numerator, is some number right around 3 being divided by some very, very small negative number. So again, if I take something like, 3 divided by -100,000, it'll be something very close to 0, but on the negative side. Okay, so that means, again, it's going to be approaching 0. Won't actually get there. We're still going to have our hole, but we know it's going to be approaching 0 on the negative side. All right, so let's see if we can put this together. So I've got this area here in between these 2 points. Well, I notice f is positive, g is negative, so it means the result will be negative. So it'll probably look something like that. And then to the right of 1, but to the left of the asymptote, I see that they're both negative. So in this area here, the quotient is going to be positive. So that means this has to go to positive infinity. Okay, that point was helpful. And similarly here, they're both positive. So when I divide them, the result is still going to be positive. So again, this is also going to go to positive infinity. All right, let's take a look at this section here. Positive and negative, meaning the quotient's going to be negative. So this has to go to negative infinity. And then here, this is where we have to do, again, a bit of analysis for the end behavior. Because I've got f, which is a large number, getting larger, divided by g, which is also a number that's getting larger. However, despite the fact that we don't have the equations, it seems pretty clear that this function f increases much more quickly than this function g. So I want to divide this really big number by just a sort of big number. The result is it's going to be very large. So I should expect the end behavior to be approaching positive infinity. Okay, let's go now to the left here. Well, again, positive and negative, meaning when I divide them, the result is going to be negative. And since I have an asymptote, that means this is going to go to negative infinity. Okay, and here they're both negative, so when I divide them, they'll be positive. And again, I need to figure out the end behavior. But we have something very similar to what we had here. We have something that's very, very negative being divided by something which is getting negative, but not quite as quickly. Okay, so first of all, when I divide them, they'll be positive, and this is going to be the one that takes over. So that means we expect this to, again, go to positive infinity. All right. So just to recap, I just went through my system of first determining the x-intercepts. All right, then I determined, in this case here, some nice points wherever they were equal. I know the quotient is going to be equal to 1. Then I figured out where I had my asymptotes and holes. So 2 asymptotes, 1 hole. And then from there, I determined my end behavior and put all this together to sketch the graph of the function. Okay, let's see how well we did here. So we'll make this a little smaller. And let's take a look at what we have. Okay, so let's bring out the quotient. And we see that we did a pretty good job, because look at this behavior here. I guess it happens to be growing a little faster, but we still had the right idea. We've got this sort of parabola type shape here. Okay, and lastly, again, this matches pretty well. Again, this seems to increase a little more quickly than what I drew, but still we have the general shape. That's correct. All right, so that's it for this one.